Hello everyone, I am Deepika Ainapur, Assistant Professor, ECE Department from KGDD College of Engineering and Technology. In the last video, we have seen about the random variable. Now, we will see the distribution function. So, this distribution function, it is called as cumulative probability distribution function. It can be written as CDF, or it can be just called as probability distribution function. It is a function, so it is represented by fx of x. This cumulative probability distribution function will be equal to probability of x less than or equal to x. This x is nothing but it is the random variable which we have discussed in the last video, and this is the real number. We will be taking all the probabilities of random variable which is less than or equal to a real number x. So, that is the meaning of this. This is nothing but cumulative distribution function fx of x. It will be represented like this. It is a function which is nothing but it is calculating all the probabilities. We are calculating all the probabilities of x random variables which is less than or equal to a real number x, and this real number can be between minus infinity to plus infinity. The real number extends between minus infinity to plus infinity. This is the cumulative probability distribution function. It is a function which is taking all the probabilities into consideration. We are calculating all the probabilities of the random variable less than or equal to a real number x. So, that is called as cumulative probability distribution function. We have some of the properties for this cumulative distribution function. So, just we will see the properties one by one. Yes. So, whenever I am taking the function fx of minus infinity, just it will be equal to 0. So, fx of minus infinity will be equal to 0. Just we can verify it by the formula. This function fx of minus infinity, how it is written? Fx of minus infinity, it can be written as probability of x less than or equal to minus infinity. So, as the real axis will start from minus infinity, less than or equal to minus infinity, there is no number, right? There is no random variable, there is no number. So, just I can say that fx of minus infinity, that is cumulative distribution function of minus infinity, will be equal to 0. In this, one more we will see, one more property of the cumulative probability distribution function, or CDF. It is called as, in short we will be calling it as CDF. Fx of plus infinity, it will be equal to 1. That is complete probability, the complete cumulative probability distribution function. Fx of infinity means all the real numbers, all the numbers on that axis will be coming into picture. So, fx of infinity will be equal to 1. How we will be calculating? Fx of infinity means what? Probability of x less than or equal to infinity. So, less than or equal to infinity means all the numbers will be coming, all the real numbers will be coming into picture. So, just total, what is the total probability value? Total probability value will be always equal to 1. That is why cumulative distribution function of infinity will be equal to 1. And we can say the next property, That is, what will be the range of cumulative distribution function now? The range of cumulative distribution function will be just from, because the lowest range is 0, highest range is 1. So, it will be extending from 0 to 1, which can be written as 0 less than or equal to f(x) of x less than or equal to 1. The complete range, because from these two we can say that the complete range of cumulative distribution function is ranging from 0 to 1. So, yes. Next property, it is like always the distribution function will be increasing, it is monotonously increasing function. Whenever the real value is increasing, the distribution function value also will be increasing. That will be represented as f(x) of x1 will be less than or equal to f(x) of x2, right. Here the given that condition should be x1 should be less than x2. If x1 is less than x2, that is f(x) of x1 is less than or equal to f(x) of x2, means this it is like it will be something like step function. It is increasing monotonously. When x1 is increasing to x2, if distribution function is also increasing from f(x) of x1 to f(x) of x2. So, that is we call it as cumulative distribution function as increasing, monotonous increasing function. Stepwise it will be increasing. This we will see with the example problem. So, f(x) of x1 will like always it will be less than or equal to f(x) of x2. Function, it is increasing function. This shows that it is an increasing function. Next, whenever we want to calculate the probability value, probability of x1 less than x less than or equal to x2, this probability value if we want to calculate, we can subtract the cumulative distribution function of x2 from x1. We will be getting the probability value from x1 to x2. Just we will be doing f(x) of x2 minus f(x) of x1. Just we will be subtracting the cumulative distribution function values, we will be getting the probabilities from x1 to x2, probability value from x1 to x2. Yeah, in the previous video we have seen about continuous random variable, right. So, for the continuous random variable, always when we want to calculate the next value, that is f(x) of x plus just beside value, it will be almost equal to f(x) of x. That means given interval is, I had taken this example 2, 3. So, in this given interval, just I want to calculate, I know f(x) of 2, I want to calculate f(x) of 2.01, both will be equal, that only this property is same. So, practically whenever we are calculating with the continuous random variable, like continuous random variable values will be there, that time a little incremental distribution function will be equal to just beside the distribution function. So, both will be equal, that is the meaning. Now, I want you to just think of all the properties and how to prove each and every property. Just think, like why minus infinity, why the distribution function value of minus infinity we are calling it as 0, we are getting it as 0, and why the distribution function of plus infinity is equal to 1. And one small question, what is the range of . CDF, that is cumulative distribution function. From which value to which value it will be ranging? What is the range of cumulative distribution function? So, think of these things, yeah, and why the word cumulative? What is the meaning of why we have used cumulative distribution function? Just think all these things, recall all the properties which are there, and just think why minus infinity, that is cumulative distribution of minus infinity is equal to 0, plus infinity is equal to 1, and what is the range of cumulative distribution function. Yes, hope you all have thought fx of minus infinity, as I have told, beyond minus, before minus infinity, proceeding to minus infinity, there is no real number. That is the reason cumulative distribution function value will be 0. And after infinity, means up to infinity, if I take all the numbers, it is like total probability value. So, total probability value will be 1. And what is the range of cumulative distribution function? It is nothing but it is ranging from 0 to 1 as given in the third property. So, it is ranging from 0 to 1. Now, just we will take one example and try to solve the cumulative distribution function, right. So, I will take an example where two coins are tossed simultaneously. So, two coins are tossed simultaneously means always it will be 2 raised to n, 2 times. So, 2 raised to 2. So, I will be getting 4 combinations. So, how can I write the sample space? S will be equal to 2 heads, HT or tail and head or 2 tails. So, this will be the combination, this will be the outcomes of the sample space. Now, I am going to define, always with the sample space, if it is a small value, it is easy to operate, but if we are taking the applications, that is bigger applications, this smaller values will be will not be able to operate with the outcomes, because so many outcomes will be there for the larger experiment. That is why I am converting this into a random variable. If you do not know about the random variable, you can just go and check the previous video. So, random variable, I am going to define the random variable here. Random variable, how I will define here, anything you can define. I am going to define here as number of occurrences of heads. I am defining the random variable as number of occurrences of heads. So, number of occurrences of heads here, how many? 1 head is possible or 0 heads is also possible. That is why I will be writing it as one value as 0 and 1 head is possible. So, 1 and 2 heads is also possible, right. Like this I am just defining the random variable. So, what is this kind of random variable? It is nothing but discrete random variable, because discrete values are there, countable values are there, that is why it is called as discrete random variable. Now, number of occurrences of heads, just define the probability of each value. So, probability of 0 will be what? What is the probability of 0 here? How many times 0 heads is there? 1 time. Among 4 times, 1 time 0 heads is there. So, probability of 0 heads will be 1 by 4. Probability of 1 head. How many times 1 head is there? 2 times. So, 2 by 4. Total 4 outcomes. So, 2 by 4. So, it will be 1 by 2. probability of 2 heads, 2 times heads, how many times? 1 time only. So, again it is 1 by 4. So, like this we will be defining the tabular column, that is I will be writing x values, which is So, 0 can be possible, 1 can be possible, 2 is possible, and here probability of just x. When probability is 0, it is 1 by 4. When probability is 1, 1 by 2. When probability is 2, 1 by 4. Like this we will be defining all the probabilities. Now, what is our aim here is like we will be calculating the fx, that is cumulative distribution function. So, fx of 0 will be what? What is the definition for the fx of 0? Fx of 0 will be probability of x less than or equal to 0. So, probability of x less than or equal to 0. Less than 0 there is no number, equal to 0 there is a number. So, I will be just writing it as 1 by 4. In the same way, fx of 1, fx of 1 means probability of x less than or equal to 1. Less than or equal to how many numbers are there? 0 is there and 1 is also there. I will be taking these two values, that 1 by 4 plus 1 by 2, right. So, it will be what? Just we can take it as 3 by 4. So, 3 by 4 will be the value of fx of 1 and fx of 2. Fx of 2 means 0 will come, 1 will come, 2 will come, all the values will come. So, just I will add all the values. So, fx of 2 is nothing but 1 by 4 plus 1 by 2 plus 1 by 4. So, what it will be? Just it is equal to 1. So, can I I can prove that fx of infinity means all the values here means what? So, fx of infinity, I will take fx of infinity also here. So, probability of x less than or equal to infinity, less than or equal to infinity, how many numbers are there? 0, 1, 2, all the values I have taken here. So, it will be just equal to 1. So, by this problem we have proved the properties also. And what is the range now? Fx of minus infinity will be equal to 0. So, range is also we have proved, that is range also will be equal to 0 to 1. So, yes, this is about your cumulative distribution function. So, we have seen the 6 properties and we have proved the properties also. Yes. So, in the next video we will be seeing about the density function, which is the we will be seeing the extension of this distribution function, we will be calculating the density function. Thank you everyone.